Right. This is not in your notes, so you'll need a piece of paper. So don't rustle yourself trying to find it. We're going to talk a little about ratios, and then it's going to tie into some equations. So we want to think, are these ratios? Ratios are just comparisons of two numbers. And so is 3 to 2 the same as 4 to 6? So think like if I have 3 boys to 2 girls, is that the same ratio as having 4 boys to 6 girls? Those are all girls, sorry. And to know if that is the same, so over here, this would be, there's 3 boys, 2 girls, and then, whoa, I can't make another group of 3 boys, 2 girls. Not even close, right? And you might have known that just by looking, that, wow, that's not even close. And so that is a no. Two to 1 and 12 to 3. So 12 to 3, could I make that into groups that are 2 to 1? Looks like I'd have way too many in the 12 to 3, right? So saying, are these ratios the same? Are actually the same thing as if I was saying, were these fractions the same? So 1/4, 1 boy, 4 girls, 4 to 16, 4 boys, 1, 2, 3, 4, 1, 2, 3, 4, there's 8, 12, so there's a 1 to 4, a 1 to 4, a 1 to 4, a 1 to 4. So 4 to 16 is the same as 1 to 4. That's kind of very visually showing you that. I'm going to stop making those drawings, but that very visually shows you that. So you can also just think, did the first number and the last number get multiplied by the same thing? Because then you could make them into equal groups like that. So if I look at the smaller one, like 2 to 1, the first number is twice as much as the second number. Is 19 twice as much as 8? No. And if I did my boy to girl thing, I'd have some extra boys not paired up. So those are not equivalent. 1 to 4 and 2 to 8. Well, 1 times 2 is 2. 4 times 2 is 8. So they were both doubled. So there would just be 2 groups of 1 to 4 in the 2 to 8. So that is equivalent. So that's what you're going to do in C1. And then in C2, you're going to come up with a number that would make it equivalent. So 1 to 9 is the same as, the 1 now has become a 9, so it got multiplied by 9. It's multiplicative. It's a multiplication relationship, not an addition. So then we also multiply 9 times 9. So that would be 81. So 1 to 6, one egg for 6 cups of flour. So if I do 3 eggs, I would need 18 because I multiplied the 1 by 3. 3 times as much, 3 times this. So here the 1 was at the end, and we changed the last number. So 1 times 11, so 11 times 9. So now we're making it smaller instead of larger. So the 2 up here became a 1. So dividing by 2, or we can think of it as multiplying by 1/2. So 10 divided by 2 would be 5. So we're going to do some work in the C's there with identifying and finding ratios. So C1 and C2. Then for now at least we're going to skip down to solve proportions. And sometimes you're going to be able to just see a relationship like we were doing just a minute ago. For instance, I see the bottom number became 3 times as big. Or if I went from right to left, divide by 3. So I could do 18 divided by 3. Since this is D, sorry about that. Since this is D over 12 is equal to 18 over 36. To get from here to here, divide by 3. So then here to here would also have to be divide by 3, which would make that 6. And you might have guessed it, my stylus is not with me. You might also notice that 18 over 36, 18 is half of 36, 6 is half of 12. Now, another way that always works is cross products. So if you think, I will never figure those out, like 6 doesn't go into 8 up here, so this gets a little tricky. So when we do proportions, even if they were written in a ratio with the colons, the ends have to equal the means. Your extremes and your means have to be the same. Here's what I mean by that. Just means when we crisscross multiply, the cross products have to be the same. Okay, the cross products have to be the same. And if you saw the notes that I posted in Google Classroom, you'll see there's information on there about that. And we're going to look at that a little bit in a minute. So if I crisscross, this would give me 8j is equal to 6 times 12. And then I solve that one-step equation. So j is equal to 9. And if I look at those two fractions, 8 over 12 or 6 over 9 would both reduce to be 2/3. And this lesson is just going to get bigger. The numbers are going to get bigger. You can always use cross multiply. If I'm not holding a calculator, so like here I see, for instance, that 50 divided by 2 is 25. So 40 divided by 2 is 20. If I cross multiply, I do get the same answer. 50w crisscross is equal to 40 times 25, which is 1,000. And then if I divide 1,000 by 50, that's where I get 20. That's not what I did initially, but both ways give us the same answer. So again, this one I couldn't use that strategy. I can crisscross though, always. Even when it doesn't come out to be a whole number, I can use cross multiplication. So 15 times 12, and then divide by 18. So the parts of the proportion that are both numbers, the crisscross partners that are both numbers get multiplied, and then they get divided by the guy who doesn't know his cross product partner. So 15 times 12 divided by 18, because 18 is across from the A. And, I think that was 10. All right. So in IXL, it's on the board, but C1, 2, and 5. C1, 2, and 5 are the 3 lessons in IXL. All right, this is like take 3 for me to try to get this done. So I apologize for the choppiness. Had some internet connectivity issues. So after you've done those IXL lessons, some of this is going to be review of what I already showed you. These are the notes that are posted as material in Google Classroom. And so a ratio is a comparison of two numbers. It can be written as a fraction with a colon or with the word 2. So 3/4 or 3 to 4, 3 to 4, 3 to 4. When it's written as a fraction, we usually interpret that as parts out of a whole. But it could also be a part-to-part relationship if it's a ratio. Like 3 boys for 4 girls. Like your class could be for every 3 guys, there are 4 women. So a proportion is a statement that says that 2 ratios are equivalent or equal. And they gave us an example here that we already know. They actually gave us 3 different ratios that are equal. And what you're going to see is that if I take those ratios that are equal, if I take any 2 of them, like 6/12 and 3/6, that their cross products, when we crisscross, will always be equal. And I think we can agree that 6/12 and 3/6 are the same thing because we know they're both equal to 1/2. But look what happens. 6 times 6, 36. And if I crisscross in the other direction, 12 times 3 is also 36. That will always happen if the 2 fractions or the 2 ratios are equal. And that 6 and 6 in that case, those are called our extremes. And the 12 and 3 in my example, the purple, are my means. I'm not going to ask you which ones is the means and which ones are the extremes. Just know that they have crisscross partners. So a top times the other bottom. You're not going straight across. We're not multiplying the 2 fractions. We're doing cross multiplication across an equal sign. So it's a different kind of thing than actually multiplying with fractions. So because that's always equal, if we have a missing number, we can find the missing number. So because my cross products have to be equal, 3 times v has to be equal then to 5 times 6. And you could write 5 times 6 first, but we could probably just do that in our head. And then it's just a one-step equation. So like what I had shown you on IXL. So this would be v is equal to 10. And if you think about the fraction 6 over 10, if you put it back in there, it could reduce down to 3 over 5. So again, we could use, just like seeing a pattern, 3 times 2, is 6. 5 times 2 makes 10. So sometimes you might not find you need to cross multiply. You might just be able to kind of use a pattern like times 2 to find out that the 10 is what would have to be missing. Because remember, you're trying to find the number that would make the two fractions equal. But we're going to get into some problems now, and if you happen to venture into the challenge zone on IXL and C5, you would see these numbers. And this is an important assignment that I normally cover on paper, and this is going to be the assignment, like the assignment that you have. Things got a little harder now. Now, it's not just an x down there. We're still going to do our cross products though. So 2 times the x plus 9. Now it's not just 2 times x, it's 2 times that entire denominator. And then when we go the other way, then I'm doing 6 times 8. And I'll just put that in red so that you see where that's coming from. And then now I solve that. Now it's a multi-step equation. So now it says down here 2-step because they did distributing on the way. So now I can do, I don't know why it's making a circle, 2x plus 18 is equal to 48. And then I've just got to do my usual equation solving that you guys have gotten really good at. So 48 minus 18 is 30. Divide by 2. And x is 15. Ta-da-ta-da! All right, so, and if I plug it in, 15 plus 9 would be 24. So we're saying that 8 over 24 is the same thing as 2 over 6. So I can cross multiply to check. I could also reduce this. If I reduce it, this is 1/3. Those are dots for divide. They're not showing up very well. And if I reduce this by 2 over 2, this is also 1/3. So yes, they are equal. So our x is equal to 15. So when you cross multiply, you would not necessarily need to write down this step as long as you remember to distribute the 2 times both as you write it down. So we'll try another one. Oh, now we've got expressions in 2 places. It's okay, we've had equations with more than one variable. The variable, well, the same variable, but happening more than once. So we're taking the 10 times n minus 1. So that's 10n minus 10. So I just went ahead and distributed that. And then I'm going to go the opposite cross product. Now, whichever one's in which spot, it doesn't matter to me, but I'm always going to think about that constant, the 8, times the n, and then go left to right. So that is the same as 8n minus 40. It is not the same as 40 minus 8n, because the 40 is the part that needs to be negative. Once we've got that, so just look, I just distributed as I wrote it down, as I did my cross products. Now we need to do what we were doing yesterday with equations with variables on both sides. I'm going to get my variables on the same side. So I'm going to get rid of these 8n by subtracting 8n. Now I have 2n minus 10 is equal to negative 40. Now it's a two-step equation. I'll add 10 to both sides. Then I have 2n, watch your signs, that's going to be negative 30. And then when I divide by 2, n is equal to negative 15. Now if I would plug negative 15 into the original proportion, this would become 10 over negative 15 minus 5 would be negative 20, and 8 over negative 15 minus 1 would be 8 over negative 16. And then I could check those cross products to make sure they're the same. You might also notice that both of those are equal to 1/2, and they would both be negative 1/2 because the bottom number is negative. Or if I tried to divide on a calculator, the left side and the right side would both equal negative 0.5. So there are many ways that you can check your final solution. You always can check. So what you're going to see on the next 2 pages, although I'm not going to look at both pages, but you should have 4 total pages in that, like resource materials is what it called it. This is the same as what your assignment page looks like. And this first problem up in the top left, I worked out for you. Okay, it's all worked out for you. My expectation for you is that you will work one of them completely out, typing all the steps. The other ones on the page, I don't expect you to type out all the steps unless you want to. My expectation is that you would do it on paper and just type your final answer. So you have 10 problems. You're going to have 10 problems. One of them I've already done, so you basically have 9 problems. And then if you look in the materials, you'll see that you have these other problems in the materials. I'm not assigning those, but I will do another example from that. Notice that it does not matter where the x parts are. You are still cross-multiplying. So I'm going to go ahead and do number 11 here as another example. Except I'm going to make it a little bigger. Again, number 1 is already worked out, but I'll do number 11 and then maybe number 16. So notice they look kind of different because those x, the parts that have x are in different places. So crisscross. So the 10, no matter which order I'm looking, I'm going to think of that constant times both terms. So 10 times x, because it's like this is in parentheses even though there aren't parentheses. So 10x plus 60. So the 10 times that entire numerator, and then the 9 times this entire the 9 is a denominator times that entire numerator. So 9x plus 54. So one top times the other bottom. Once I have that, now it's a multi-step equation. These are going to get very predictable. Cross multiply, being sure that you distribute. Get your variables on the same side. Then get your constant to the other side by adding or subtracting. And then in this case, I did not have a division step. Most of them you'll have a division step. Here I don't have a division step because 10 minus 9 was just 1x. If I plug it in, negative 6 plus 6 is 0. On the other side, negative 6 plus 6 is 0. 0 divided by 9 and 0 divided by 10. They're both 0, so it's okay. It works. It's true. So crisscross 4 times x plus 5. So that's 4x. 4 times the 5 plus 20. Now we're going to equal sign in the middle. That's important. If you forget that equal sign, things are not going to go well. Now we're going to crisscross the other way. 5 times x. 5 times negative 5. So 5x minus 25. I'm a creature of habit. I'm going to move this to the left, just because that's where I like it. Nothing magical. So negative x plus 20 is equal to negative 25. Then I would subtract the 20 and get negative 1x is negative 45. And then since I chose to put mine on this side, I'm going to have another step where I have to divide by negative 1, which is just x equals positive 45. Had I put my x, if I had subtracted the 4x first, I would have just had 1x on the right, then I would have added 25, and I would have had 45 equals x. My final answer is still the same. And notice if I plugged it in up there, if I plug this number in for x, it's going to say 4 over 5. 45 minus 5 is 40. 45 plus 5 is 50. And hopefully we all recognize that 4 to 5 is the same thing as 40 to 50. So 4 parts out of 5 is the same as 40 parts out of 50. All right, so you have this copy. If you want to do extra practice, it is in the materials on Google Classroom. There's nothing to submit for that part. The part that you'll submit says algebraic proportions, and you have 9 problems to do on that page. There's 10 on the page. 1 I've already done. 1 additional problem, I want you to type out the steps. The rest you can type out, but you can just simply do your work on paper and then type in the final answer. There are a couple problems at the bottom of the page. You might not have enough space to type all the work. But remember, you are only required to type the work for 1 of them. All right, great job. And we will be doing some applications with proportions on Monday. Remember again that the IXL lessons that I expect done are C1, 2, and 5. And then the worksheet with the 9 problems you need to finish. Thanks and have a good day.